All right, today we got to review probability for the final. Probability is the favorable over the possible outcomes. You got to know that formula because it comes into every single probability problem. And there's probably about 25 out of 80 questions on the test are probabilities. Experimental versus theoretical. Experimental probability is where you actually try something to see what the probability is. And theoretical is where you just calculate what it should be. Like a coin, if you just say, oh, it's got two sides, should be theoretically 50-50. But experimental is where you actually flip the coin and see how many times it comes up heads. Independent versus dependent. I like cards for this, so I'm going to use a card example. You can't see it at home, but I have a deck of cards here. How many cards are in a normal deck of cards? 52. And how many of them would be hearts, for instance? 13. So, would you draw one? What's the probability she's going to pick a heart? 13 out of 52, which is 1/4. All right, let's see. What'd you get? 10 of diamonds. So keep it out. And now, what's the probability she's going to get a heart? 13. There's still 13 hearts in here out of 51. Try it again. Did you get a heart? No, 7 of spades. Okay, I keep it out. And now what's her probability? 13 out of 50. Come on, find a heart. No. Now we got 13 out of 49. 13 out of 48. 13 out of 47. 13 out of 46. 13 out of 45. Starting to think the deck is rigged. 44. Yes, finally. Okay, now, all of a sudden we finally changed something. So we finally got one. So we changed it to 12 out of 44 chance. We'll just do one more. Did you get one? Ooh, she got 2 in a row finally. Kind of makes up for all those other ones. All right. So that, when she kept the cards out like that, it changed the probability each time. That meant it was what? Dependent is correct. All right. Anytime you're looking at two events, if the one affects the other one, then it's dependent. All right. If you have a roll of die and then you flip a coin, do they depend on each other or not? No. So they would be independent. How about number 2? That's the one we just did. How about number 3? You're choosing class president and vice president. First we pick the vice president, and then we pick the president. It doesn't normally work that way, does it? You'd normally pick. I mean, if I was doing it, I would think you'd pick the president first. You know, as like the most, I don't know, respected or popular person or whatever it would be. And then when that's done, then you'd pick the vice president. But let's say they do it this way. Either way, would the results of the second thing be affected by the results of the first thing? Yes, because there's one person that can't be president anymore because they already picked the vice. So yeah, those would be dependent. And then this lottery ticket one. You buy one today, you don't win. You buy one tomorrow, does it affect it that you bought one yesterday? No, they don't. It's independent. All right, moving on. Mutually exclusive. Exclusive things are ones that are meant to be like really special or separate. So I'm going to explain exclusive with a real world example from my own experience. There's a golf club not far from me that's really nice. Got fancy, nice greens and everything. It's a really nice club. It's not. It's just down the road from me. So I drove in one time, thinking I was possibly interested in joining. So I talked to them, and they said, "I'm sorry, but you have to be asked to join. You can't just come up and join the club. So you have to be asked by a member." So I was like, "Well, fine. I don't want to join your stupid club anyway." But if you're that exclusive, then you're trying to separate yourself from the general public, because the people that join that club want to have just basically their friends all in the club. They don't want to have people from outside that they don't know playing golf on their course, I guess. So I ask you, as you look at these two circles overlapping each other, do you think that these are mutually exclusive events? If you know now a little bit better what exclusive means. I think most people think the answer is yes, because the title at the top is mutually exclusive, and the first picture you see, you'd think it was an example of mutually exclusive, but it's not. These are not mutually exclusive events, because they are things that can overlap. So therefore, you can be both. It's like science and math. If I say, are you in science? Are you taking a science class? Yeah. Are you taking a math class? Yeah, so you'd be in the overlap area, okay? There's a lot of overlap there. So those are not mutually exclusive. Because, but there are some things that are either one or the other. Again, there's almost always an exception. There's almost always a rare exception where you can be both, okay? Like you could say, here's one. Do you have really long hair? If you have really long hair, then you can't say that you have really short hair, right? Or can you have, how about the mullet? See, then you got, you know, chick mullet. Short hair in the top, long hair in the back. All right. What do they say about the mullet? It's like business up front and party in the back. Yeah, okay. Anyway, so even with hair, you can't win. Pretty much everything overlaps. So very, very few things are mutually exclusive in the real world, but in math, they can be more often. All right. So all these Venn diagrams are not mutually exclusive events. They are things that overlap each other. Because otherwise, if they didn't overlap, it wouldn't be a Venn diagram. All right, this one has math and science just like we were talking about, but this must be a different situation, like maybe in college where not everybody even takes math in the first place. And I took a lot of math, but I only took like one science class in college because I was focusing on math. So and some of you guys might take, well, you guys are all good at math in here, so it might be a biased sample. But anyway, let's say this is college students, and the 0.4 does not mean we had 0.4 of a college student who was taking math. Therefore, that's probably a probability, right? So this is a probability Venn, as opposed to what's the other kind? Oh, better write it down then. Okay, here's the two kinds of Venns. Write these on your notes. Probability Venns and frequency Venns. Those are the two kinds of Venns. Probability and frequency. All right, this one is a probability Venn. And the other kind where if I had like 25 people written in the circle, then that'd be a frequency Venn. So what do each of these four regions represent? I think we'll get to that as we, well, you know, I suppose we should. One of the questions on the test is something like this, where it says, tell what each of these regions is. Well, this one right here is people that do what? They math. And I like it when you said only math, because these people also do math, but they do math and science. And then these people, only science, good. And these people, they don't take math and they don't take science, neither one. All right, now let's do these probabilities one by one. Probability of math. What do you think the common mistake answer is that will probably be one of the answers? 0.4 will be A, B, C, or D, and then you won't pick 0.4 though, will you? What will you pick? 0.7 would be the right answer. Next one, probability of science. 0.5, good. Math and not science. 0.4. Math and science. 0.3. Now this is counterintuitive because to me, if I say you and me, that means like both of us together. It seems like this should be more than one of these should be circled, but it's only that one. And that's also counterintuitive when you get to or, because or, it's not this or that, it's which ones? Oh, the math or science, all of these. And again, counterintuitive. Now the symbols, I don't know if you noticed on the other screen, I'll go back to it in a second, but that's the sign for union. That means that all of them, so the or could have been replaced with a U for a union. You might want to write that one down too. Or goes with union. And what does and go with? Well, it goes with, it's kind of the opposite. It goes with the upside down U, yes. This is the intersection. That goes with and. And means intersection. And that makes more sense. The word intersection, intersect, where they two intersect. And so the symbols are not counterintuitive, they're intuitive. A union to me, anyway, seems like everybody all together. The union means all of those. Okay, moving on. Let's talk about expected value. Expected value is where you're trying to figure out how much is this worth. This is there's a probability involved in it. That's why we have it in this chapter. But there's a probability, and then there's an amount involved usually, either amount of money or amount of kids that you're having. Do you remember the formula that I told you a bazillion times, Ms. Kemp? I think you know it. P times A, then add. Please write that down on your paper, because I can guarantee most of you didn't remember that. All right, P times A and then add. We will finish this problem on the second part of the recording.